Creighton is very engaged in drug discovery research, where we do the actual biologic screening. The people in my lab that actually do this biologic screening are postdoctoral associates, graduate students, undergraduates, and technicians. We have an NIH-funded research project that has an overarching goal to develop treatments that could be ultimately used in humans after a stroke, after a traumatic brain injury, to help the brain heal. The drugs that we're using, they're actually natural products that come from marine algae, that is algae that are in the ocean. These compounds actually promote wiring of mouse neurons that we grow in culture. The target for these drugs are protein in humans. This protein is called a voltage-gated sodium channel. Now that sounds like a complicated term, and it is, but everybody knows about these channels, because if you go to the dentist, you want those channels blocked before the dentist starts treatment. The drugs that we're using do just the opposite. They turn the volume up on these voltage-gated sodium channels. And when you do that after an injury to the brain, that helps neurons grow and attempt to rewire. We know that there's a very large literature that exists on what we call neuroplasticity. Plasticity refers to the brain's ability to change. Your brain changes when you learn something. Your brain changes when you go to sleep at night. We call that neuroplasticity. So we want to promote neuroplasticity after a neural insult, after a stroke or a traumatic brain injury.